Predict the product of the following electrocyclic reaction. So how can we predict the product of these reactions? Well, one thing we have to know is before predicting the product of this reaction is the condition of the reaction. The condition of the reaction, and for how the product is going to form, we know that for the product to form, we know that since it is electrocyclic reaction, we are going to use one of the pi bond to form a sigma bond. Definitely right here. But how is the stereochemistry of our product going to look like? So there's a certain rule that we have to know from Woodhoff-Mann's rule. So if we have 4n pi electron system and 4n plus 2 pi electron system, the result that we are going to get are this. So for 4n pi electron system, under thermal condition, we are going to get Conrotatory, and under photochemical condition, we are going to get Disrotatory. So here too, under thermal condition, we are going to get this and here Conrotatory. And we know when we have Conrotatory, what is the stereochemistry for Conrotatory? We know for Conrotatory, we are going to form trans, right? Trans, yes. Like what we did earlier, we know for Conrotatory, we got trans. And for this, as the name this, it sounds like cis, right? Cis. So we're going to find the sixth product, right? Good. So now what we have to do is to look at our molecule. Is it the 4n pi delocalized electron system or the 4n plus 2 pi delocalized electron system? And how do we know if it is the 4n pi delocalized electron system or 4n plus 2 pi delocalized electron system? So now let's looking at our 4n here. Let's n start from 1 by indicating multiples of 4, right? So if n is 1, we are going to get 4, right? So we can have 4 pi delocalized electrons, which means 2 bonds, right? 2 double bonds in the system. So if n is 2, we are going to have 4 by 2, right? Which is going to give us 8 electron delocalized electron system. So which means we are going to get how do you say? We are going to get 8 double bonds in the system, right? So 1n here, let's take it to be multiplied by 1, indicating like multiples of 4. We are going to get an electron system that is a multiple of 4 as far as 4n is in concern. So if you look at your electron system, is it a multiple of 4 or is it a multiple of 4n plus 2? For 4n plus 2, when n is 1, we are going to get 4 plus 2, which is going to give us 6 electron system, right? When n is 2, we are going to get 8 plus 2, which is 10 electron system, right? When n is 3, we are going to form 12 plus 2, which is going to be 14 electron system. So that is how you can apply this. So now that we know this, let's try analyzing our molecule. In this molecule, how many electrons we have? Pi delocalized electrons we have. So we have 2, 4, 5, 6, 7, 8, right? You will see that it is 8. When you have 8, you will see that it's a multiple of 4. 8 is a multiple of 4, right? So 4 by 2 is going to give you 8, right? Since 8 is a multiple of 4, that means we have the 4n delocalized system. Do you get that? If it happens to be 10, then you could see that we have additional 2 adding to a multiple of 4. 12, you will see that we have additional 2 adding to a multiple, then you will say that it is 4n plus 2 pi delocalized electron system. So let's go ahead. Now that we know this is our 4n delocalized electron system, let's go ahead and detect our result. So we have our 4n, so we start on 4n pi delocalized system, and then what else again? The reactions is under photochemical condition, right? Photochemical condition. So we are going to form the disrotatory form. And we know this is going to give out the sixth product. And the sixth product is just a meso compound, right? Good. So let's do that. Now you are mature. Do you know that this electron will move to that side, and this one will move to this side, this one will move here, and this one will move to form a sigma bond. So I can draw my product like this, just like this. So you see that this electron move to that side. So we are going to have something like this. This one move to that side. Bond will be here, and this one move to that side. We have another one here. That one move to the side. So at the end of it, you can see that it's an electrocyclic reaction. So we have 4 bonds, and our product is going to contain 3 bonds. One of the bond is converted to sigma bond. So that's how we can. That is the answer for this question. And now let's look at this. What electron system do we have here? We have 2 bonds, which means 4 electron system, right? Which means n is 1, 4 is a multiple of 4, right? So and the reaction is under photochemical condition and then thermal condition. So we know the photochemical condition, we are going to form the dis, which is a cis product, and then for thermal condition, we are going to form the conrotatory system, which is the trans system. So how do we draw this? First, let's see how our product is going to look like. So these one are substituents. Don't forget substituent, right? So when this bond moves to that side, this one will also move here to form a sigma bond. It should rather be here. So we are going to get something like this, something like this. We've got this bond to move here to form a double bond here, and this double bond was distracted coming here, right, to form a sigma bond. So we've gotten only one bond here, double bond. And we know that for our conrotatory, we are going to get the cis enantiomers, and the cis enantiomers are we are going to get cis enantiomers, right? Which means we can get CH3 to be here, sorry, on dashes, and this one will be on wedge. Our hydrogens will be here, and these two hydrogens will be there. And for the under photochemical condition, we are going to form the disrotatory. It's the disrotatory system. So we are going to get the cis product, right? Cis product meaning that the the substituent are pointing the same. So we have our hydrogen here and our hydrogen here. So cis trans enantiomers. Let's look at our last example for this video. So this is our last example, and it is under photochemical condition. So now let's look at our power system. 1, 2, 3, 4, 5, 6, right? We have 6 electrons, right? 6 power system. So you can see that we have a multiple of 4 here and plus 2. So this is definitely going to be the 4n plus 2 rule, right? So for 4n plus 2 rule under photochemical condition, what do we get? 4n plus 2 rule under photochemical condition, we're going to form the conrotatory. So conrotatory also gives us the trans product, right? So let's do that. So when this rotate to this place, this one also move to that place, and this will move here to form a sigma bond. So what is going to indicate that this is a trans product? What are we going to base on? Mind you, we have hydrogens here, right? So there can be a situation where our hydrogens will be on the das wedge, and our hydrogen here will be on the solid wedge, or our hydrogen here should be on the solid wedge, and our hydrogen here should be on the das wedge. So that's it for this video. And don't forget to bring the high electrons. So we was 3 here, one gone to form a sigma bond, so we are getting 2. So where are they? So this one moves here to form a double bond here, that we're getting a double bond right here, and this one also moved the other way to form a double bond right here. So that's it. So that's it for this video. Don't forget to check other videos on the cycloaddition and the sigmatropic rearrangement. Thank you for watching, and don't also forget to support this channel by subscribing, liking, and sharing to keep me moving smoothly. Thank you.